In this last Let's Take a moment, I want to talk about the importance of convection, because I fundamentally disagree with your author, okay, on this topic. Your author suggests that convection is not the main driving force. However, slab push and slab pull is the main forces. However, convection is what causes slab push and slab pull. So I want to take a moment to understand how convection drives plate motion. So let's just draw a very generic overview here, okay, of what's going on. So here, all right, let's go ahead and do this the right way. So here we have our lithosphere. And down here, right, we have our asthenosphere. All right. We know that the asthenosphere convex. We talked about this in one of our very first Let's Show Me's, right? So remember, the core of the Earth is hot. It's going to heat up the asthenosphere. The asthenosphere is going to become less dense and it's going to rise. Right? Now, as that asthenosphere sits up top here for a little bit, it's going to get cold, so it's going to become heavier, and it's going to eventually sink, right? And that's our convection. So we have these motions, right, that are going on, these convective motions going on in the asthenosphere. And if we really think about it, these convective motions are what's really driving the plates. So if I have two convection cells that are, say, doing something like this convection cell here is pulling the plate in this direction, which means this is going to be moving this way. This convection cell is pulling the plate in the opposite direction, which means this is going to be moving that way. So what do we create right here? Hopefully with a resounding answer, you said a divergent boundary. Right here my plates are moving apart from each other. But what if I have convection cells that, say, do something like this? Right? So what's going to happen here, let me erase some of this so I can draw what's properly going to happen. What's going to happen here is this convection cell is pulling this plate this way, and this convection cell is pulling this plate this way. So my plates are going to collide with each other. Now, as we've learned, let's say this one over here on the left is a continental plate. So remember, it's light and buoyant. Well, let's say the plate on the right is an oceanic plate. It's going to get sucked underneath. And now it's going to get pulled by both of these currents and go down, right, to get remelted. So convection is really pushing and pulling these plates. Now, to add a little bit more complexity to this, right, I've drawn for you that our convection cells look like this. However, I do not want you to think that they are like the wheels of a tire, right, that are constantly going around. It's more like a basketball. So if we think of a circle, right, this circle can move this way, it can also wobble this way, it can wobble this way. Think of a spinning basketball, right? The top is spinning slower than, or the top is spinning faster than the middle, than the equatorial part. So really this is more like a three-dimensional bubble, right? And that bubble is kind of wobbly. So really we don't have a tire-like motion, but it's a much more complex motion. But I do think it's important for you to see that this convection cell drives slab push and slab pull. So if it weren't for the convection cells, we would not have those two. So hopefully you can see now how convection drives the plates and how they move.